Very good morning and welcome everyone to this course Physics 1. This course is generally made for undergraduate level BTech students. Myself, Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baroipur. You can meet me personally at college premises, ground floor physics lab. You can also send me a mail regarding your query and doubt to that given mail ID, that is godphysics6@gmail.com and gopal.chakraborty_gkcem@gisgroup.org. You can also subscribe my YouTube channel for more videos. So I am the subject teacher for this course. Now the course pages are www.markoutexam.net. Another one is www.markoutwb.ac.in. So you can find the syllabus is already uploaded there in the university website. The title of the course is Physics 1. The subject code is BS PH101. It is under the category of Basic Science and Humanities course. So credit 4 and it has a lecture 3 per week and 1 tutorial per week. The course is made for generally BTech degree students of first year. So the students, those are taking admission in the first year BTech degree, they are already passing out the HS. So they have the basic knowledge regarding this course, regarding physics. So they have to know or study well in a details all about this course. So for the first sem or odd semester, computer science, civil and mechanical departmental students will going to study this course, and alternatively electrical and electronics departmental students will going to study this course in the event semester. Today the topic that I am going to cover are potential energy function F equals to minus of grad V, equipotential surface and meaning of gradient, moment of inertia and calculation of moment of inertia for different system. So these topics are also under the module 1 mechanics. Prerequisite for this course is elementary idea of physics and fundamental idea of mathematics. Course objectives are: learn about potential energy function F equals to minus of grad V, equipotential surface, learn about moment of inertia and moment of a rigid body in a plane. So after completion of this course, students are able to calculate moment of inertia for different body. They will also understand the physical significance of moment of inertia, basic idea of potential energy function and equipotential surface. In my last video tutorial, where I have discussed regarding the Newton's laws of motion, conservative force, non-conservative force, momentum, energy, work done, in that video I have discussed about conservative force and non-conservative force, which is basically important for today's class, because that concept is needed to know the energy gradient or potential function. It is very important for you. Now the first topic is potential energy function F, and I will show you how that value of F is equals to minus of grad V. So potential energy capital V further for a force capital F is Vi if we consider that Vi is the initial value of potential or the value of the potential at initial position, and Vf is the value at the final position. The distance between the 2 points is irrelevant here, as the gravity depends only on the initial and final position of the object. A potential gradient is a local rate of change of potential with respect to displacement. So, here in this diagram, I will explain you how you will calculate the value of the potential energy function F. Now, in this diagram, what I will show that initial position is 1 and the final position is 2. So, particle starts moving from 1 to 2 through the path A and then again comes back to the point 2 to 1 through the path B. So W1 is the work done by the particle when it's going from point 1 to 2, and W2 is the work done for that same particle when it's come back from point 2 to point 1. So, as per conservative force, we know that total work done is conserved. So, W1 will be equals to W2. So, as we know, the work done means integration of F dot dr, force into displacement. So, F dot dr will give you the work done. So, total work done will be equals to 0 as per conservative, as the force are conservative force. So, by applying Stokes theorem. So, what is Stokes theorem? I have already discussed in details regarding the Stokes theorem in the video of vector calculus part 2 or part 3. Now, here the Stokes theorem actually relates the line integral, closed line integral to a surface integral. So, if you substitute or if you apply the Stokes theorem in the left hand side of that equation or expression, which is integration of F dot dr is equals to 0, what you will get, that integration of F dot dr will now change closed surface integral del cross F dot dA is equals to 0, where dA is the infinitesimal surface area. Now, as dA is an arbitrary area bounded by the curve AB, so dA can't be 0. dA may be infinitesimally small, but it can't be 0. So, to satisfy this equation, rest of the part will be 0. So, rest of the part means del cross F will be equals to 0. So, the direction of curl F and dA is either same or opposite, but not perpendicular. It can't be perpendicular. Okay. So, if it is perpendicular, we know that del cross F, so del F sin theta sin 90, if it is perpendicular, so it has a value. It can't be 0. That means either they are in same direction or opposite direction, but it can't be perpendicular. So, from the last equation, what we have derived, that del cross F is equals to 0. Now, we know the curl of grad V, where V is the scalar potential. So, curl of grad V is always 0. So, if curl of grad V is 0, you can compare these two equations, and that will give you F equals to minus of grad V, where V is the scalar potential. So, the force F can be written as negative gradient of a potential, scalar potential. Now, the next point, equipotential surface. So, this is also very important to understand the physical significance, or what is the actual physics behind this equipotential surface. So, by the name you can say that the potential will be throughout the surface constant. Okay. So, the surface, which is the locus of all points which are at the same potential is known as equipotential surface. So as the potentials are same, so no work is required to move a charge from one point to another point on this equipotential surface. So in the other words, any surface with the same electric potential at every point is termed as an equipotential surface. So any surface over which the potential is constant is called equipotential surface also. So this equipotential surface has different properties. So these properties are, the first one is electric field is always perpendicular to an equipotential surface. The equipotential surfaces can never intersect. So two or more, it may be a large number of equipotential surfaces, but they cannot intersect each other. For a point charge, the equipotential surfaces are concentric spherical wall. The uniform electric field, the equipotential surface are planes normal to the x-axis. The direction of equipotential surface is from high potential to low potential, as I have shown you in the diagram. Inside a hollow charged spherical conductor, the potential is constant. This can be treated as equipotential volume. No work is required to move a charge from the center to the surface. For an isolated point charge, the equipotential surface is a sphere. Therefore, concentric sphere around the point charge are basically for different equipotential surface. In a uniform electric field, any plane normal to the field direction is an equipotential surface. The spacing between the equipotential surface and the enables us to identify region of a strong and weak field. As we know, E equals to minus of dV dr, where E is the electric field, V is the vector scalar potential, and R is a positional vector. So from there you can write E is proportional to 1 by R. So electric field, electrostatic field is inversely proportional to the displacement. So from this part, hope you have understand how you will derive the energy function F, or how you will prove that F equals to minus of grad V, and also what is your equipotential surface and corresponding properties of equipotential surface. They must valid to a surface to be a equipotential one. Now the next part, that is called moment of inertia. So moment of inertia is basically the mass equivalence of the circuit or mass equivalent of the given device. The moment of inertia, otherwise known as the mass moment of inertia, angular mass or rotational inertia of a rigid body, is a quantity that determines the torque needed for a desired angular acceleration about a rotational axis. Similar to how mass determines the force needed for a desired acceleration, it depends on the body's mass distribution and the axis chosen, with large moments requiring more torque to change the positions or body's rate of rotation. It is an extensive property for a point mass. The moment of inertia is simply the mass times the square of the perpendicular distance to the axis of rotation. So for a large number of particles we can write capital I, because moment of inertia is denoted by capital I. So capital I equals to summation of I equals to 1 to n mi ri square. So I is the how many number of particle is there. So we have considered small n number of particles are there. So mi represent the total mass of that particle, and ri square, ri basically denotes the distance from the axis of rotation for all the particles or object. Now, what is the physical significance of moment of inertia? The physical significance of the moment of inertia of a body about an axis is the distribution of mass of the body in space about the axis. So, moment of inertia is related to the rotational motion as mass is related to the translational motion. Measurement of moment of inertia plays the same roles as it plays mass in translatory motion. In translatory motion is a measure of depth. Mass is a measure of the inertia. Therefore, moment of inertia is a measure of rotational inertia in rotatory motion. Now, radius of gyration. Radius of gyration or gyration of a body about an axis of rotation is defined as the radial distance to a point which would have a moment of inertia the same as the body's actual distribution of mass if the total mass of the body were concentrated. Mathematically, the radius of gyration is the root mean square distance of the object's parts from either its center or the mass of a given axis depending on the relevant application. It is actually the perpendicular distance from the point mass to the axis of rotation. So, in formula you can write I equals to m k square, where k can be written as under root r1 square plus r2 square plus r3 square dot up to rn square by n if we consider n number of particle is there. So this value is a constant k, and that k is called radius of gyration. So it means to calculate the moment of inertia, what you need to find out what is the mass of the particle or mass of the body, and what is the distance of the body from the axis of rotation. So to find out this, you have to know two theorems are there. One is perpendicular theorem, one other is parallel axis theorem. That will give you the procedure how you will solve the moment of inertia for a particular axis of rotation, because you have to measure the distance from that axis of rotation. So I will tell you what is your perpendicular axis theorem and parallel axis theorem. Perpendicular axis theorem is, this theorem is applicable only to the planar bodies which are flat with very less or negligible thickness. So as like it is a plate, you can consider it with a plate type or discs which have a very small thickness. So this theorem states that the moment of inertia of a planar body about an axis perpendicular to its plane is equal to the sum of its moment of inertia about two perpendicular axes concurrent with the perpendicular axis and lying in the plane of the body. So that means here if you consider the moment of inertia along z axis, that will be equals to the sum of moment of inertia for y axis and x axis. So next one, that is parallel axis theorem. Parallel axis theorem is applicable to bodies of any shape. The theorem of parallel axis states that the moment of inertia of a body about an axis parallel to an axis passing through the center of mass is equals to the sum of the moment of inertia of the body about an axis passing through the center of the mass and product of mass and the square of the distance between two axes. So here, as you know, if I going to find out ij dash, the moment of inertia along j dash axis, that will be equals to iz plus m r square. Here I have considered alpha square, so it is iz plus m alpha square. Now I will solve some application to find out the moment of inertia, because if you solve this kind of application or problem, so it will be very helpful for you to understand how you will solve, how you will find out moment of inertia for different devices, or how you will apply the parallel axis theorem and perpendicular axis theorem to find out the moment of inertia. So this is our first example, that is moment of inertia of a ring about an axis passing through its center and perpendicular to its plane. So here, as per the diagram, you are asked to find out the moment of inertia of that given ring along the axis y dash, because this is y dash is the axis of rotation. So how you will solve this problem? So this kind of problem, we consider the ring having some mass, say the mass is capital M. So first we consider a small element on this ring. We try to find out the mass of that small element, then by what will be the moment of inertia for this small element, because for this ring the radius r, that will be the distance from the axis y dash, that will be constant. So you don't have to worry about that distance, you have to worry about the only the how you will find out the mass, because mass of the small element, after finding out, you just finding out what will be the moment of inertia for that small element. So after completion of that moment of inertia finding, you can take the integration over the whole angle, that is 0 to 2 pi, or for the radius or circumference you can consider for the integration from 0 to 2 pi r, which will complete the total ring and will give you the moment of inertia for the whole ring. So here I have considered that capital M is the mass of the ring. So as capital M is the mass of the ring, so as we know the total circumference is 2 pi r, so mass per unit length, that will be capital M by 2 pi r. So I have considered a small element of amount dx. So mass of that element will be capital M by 2 pi r into dx. Okay. So this is the mass of the small element that I have considered. Now what will be the moment of inertia? The small moment of inertia due to this small element is di, that is equals to this mass into r square, because r is the distance from the axis of rotation y dash. So what you will get? Capital M by 2 pi r dx into r square. So if you solve, you will get capital M r by 2 pi into dx. So now you have already calculated what is the moment of inertia for this small element. Now if you take the integration from limit 0 to 2 pi r, that means that will complete the whole ring. So here I have shown you the integration that I have done. So that integration value will give you mr by 2 pi integration over dx. Limit is 0 to 2 pi r. So integration of dx is simply x. So upper limit is 2 pi r. So lower limit is 0. So if you substitute this value, what you will get? You will get capital I, that is moment of inertia of this whole ring about the axis passing through its center, that is y dash, will be equals to capital M r square. Now the second question, that is moment of inertia of the same ring about any diameter. So about any diameter means, now you may consider that the moment of inertia is along, it is any diameter, that means along AB or along CD. Okay, so here I consider that the axis of rotation is AB and the moment of inertia along this axis is ID for suffix diameter. Okay, so as we know, the perpendicular axis is ABCD along with the y dash. So perpendicular axis theorem that states that IAB plus ICD is equals to IYY dash. So as we considered the moment of inertia along diameter, so IAB will be equals to ICD, so that is ID. So here I substitute ID plus ID, that is equals to m r square. So ID is equals to half m r square. So here IYY dash, that means along the center axis, I haven't calculated because in my last problem I have already derived how the derivation was done. Okay, so here I have simply put the value. So ID we will get, that is equals to half m r square. So ID is the moment of inertia of the ring about any diameter. Third question, that moment of inertia of the ring about any tangent in its plane. So here you have to apply the theorem. So the theorem gives here now in last problem what you have done the perpendicular axis theorem. Here you have to apply the parallel axis theorem. So I tangent. So tangent means here as per diagram it is along BE or BF axis. This is the axis of rotation. So I tangent will be equals to moment of inertia about the diameter CD plus m r square. So half m r square plus m r square, that gives you the moment of inertia about this tangent to its plane is equals to 3 by 2 m r square. Now the next problem, here I have to find out the moment of inertia of a circular disc, that means it's a plate having very small thickness about an axis through its center and perpendicular to its plane. So the basic procedure is same as what we have done in case of the ring. Here you may consider the plate consists of large number of small ring. Okay, so first you consider a ring having thickness dx. Okay, so then you try to find out what is the mass of the ring, because in last problem what we have done, we considered the total mass of the ring, then we find out the mass per unit length. So here also in case of disc, the total mass you may consider that is capital M. Okay, and the mass per unit area of the disc, that can be written as m by pi r square, as it is the plate. So that is the mass per unit area. So after finding out the mass per unit area, you can easily find out what will be the mass of that ring having small thickness dx, because the area of the ring is circumference into width into dx into 2 pi x. So that will give you the area of the ring. So mass of the concentric ring will be m by pi r square 2 pi x dx. So after solving, that will give you 2mx dx by r square. So that will be denoted as small m, and small m is denoted the mass of that small ring. Okay. Now try to find out the moment of inertia for that ring. Okay. So as the ring is at a distance x, so moment of inertia will be that's m, small m into x square. So if you substitute the value of small m into x square, that will give you 2 capital M x cube dx by r square. So this is the moment of inertia for that small ring through the axis y dash. Okay, because y dash is the axis of rotation. Now to find out the total moment of inertia, again the procedure is same. You have to take integration. Now the limit is 0 to r, because here you consider the ring at a distance x from the center. Okay, and if you try to complete the whole disk, so you have to move from 0 to x, then to up to r. That means your limit will be 0 to capital R. So taking that limit 0 to capital R, and you will get, taking the integration, that is twice capital M by r square, that is a constant, you can take it common, and integration over x cube dx. So after integration you will get x to the power 4 by 4, and substituting the value of upper limit and lower limit, that will give you the value I equals to half capital M r square. So this is the moment of inertia of a circular disc about an axis through its center and perpendicular to the plane. Hope you will understand. So these are the reference book that you can refer: Concept of Physics, A.C. Verma, Laws of Motion and Friction, Dr. Sanjay Kumar, Understanding is Laws of Motion, and master books for physics, that is Laws of Motion. So these are the important books that you may refer. Evaluation process is same. You have to appear for 30 marks internal exam and external exam for 70 marks. Oh, so there is a segregation or division in the internal exam. So for internal exam, internal marks, internal exam will be for 15 marks, assignment or tutorial will be for 10 marks, and attendance for 5 marks. So with this video I have completed the chapter mechanics, okay, and also completed the first module that I have started with the vector and then laws of motion and vibration. So all these things are completed. If you have any doubt, you contact me at the given mail address. In next class I will start the next module. Thank you.